An object with balanced equal forces will continue to stay balanced and at rest unless an unbalanced external force acts upon it and causes the forces acting on that object to also be unbalanced. This is the same for if it is in motion. The object will continue in the same direction and at the exact same speed until an unbalanced force acts upon it in some way and changes either its speed or direction. In this example of Newton's first law, the soccer ball is at rest because all forces acting on it are equal and balanced. Then, the unbalanced force, aka the foot, acts upon the ball by kicking it and causes it to move. Because the ball is in motion, it will continue to move with the same constant speed and direction unless it is acted upon by another unbalanced force. This unbalanced force is the wall in which the ball hits. This forward motion of the ball until acted upon by another force is an example of inertia. Inertia is also an important part of Newton's first law. Inertia is the forward motion of an object unless an unbalanced force acts on it to change its motion. The bigger the mass, the larger the amount of inertia.
Newton's second law states that an object will accelerate, which is either a change in speed or direction if an unbalanced force is applied to it. The object's acceleration will depend on the size of the force and the mass of the object. The scientific term for this is F equals ma, which is force equals mass times acceleration. For this experiment, we decided to test out whether the mass of an object affected the acceleration of it. We tested 3 balls, a basketball, a tennis ball, and a ping pong ball. The balls here are in order of heaviest to lightest. From these times that we recorded and tested 3 times to find an average, we can see that the heavier the ball is, the faster it accelerated. In this example of Newton's second law, the amount of force applied was the same for all balls. Mass and gravity is what affected the acceleration.
Newton's third law states that for every action there is an equal opposite reaction. Thus, if one object exerts a force on a second object, the first object undergoes a force of the same strength but in opposite direction. An example of this law is a balloon. This balloon is taped to a straw and held at the neck so not to let out any of the air. Watch when we release the balloon. It accelerates along the thread. What makes the balloon move? The air in the balloon is pushed out the neck and air is pushed back inside. There is now an unbalanced force acting on the balloon, therefore accelerating it along the thread.